Hello everyone, this is James Shore with another test-driven JavaScript video. I'm recording this on August 27th, 2014. You're watching The Lab, which is where we explore, experiment, and generally mess about. And today in The Lab, we're continuing our series on front-end libraries and frameworks with part 2 of our review of React, the library for front-end components from Facebook. And in part 1 of this series, what we did was we looked at how React works, how you install it, automation, modularity, testing, basically everything we need in order to get React working in the type of professional environment that we prefer, where we've got lots of good automation. Now in part 2, we're going to look at some of the deeper questions I have about architecture and design. This is a big episode. We are covering a lot of ground. We're going to start out by just reviewing how React works and what we're trying to do here in this episode before diving into value objects and how React works with our somewhat peculiar approach to rendering. Then we'll look at form fields and how you deal with components that have state, and then move on to dealing with communication from child back to parent. It's easy to do from parent to child in React. How do you do it the other way? After that, we'll look at the larger question of how do you communicate between components across a large application where there isn't necessarily a clear child-parent relationship. And from there, we'll segue into live updating. Finally, we'll wrap up by looking at how React performs on various metrics and my final recommendations. As I said, there is a lot of content here. You can use the timestamps on your screen to jump to sections of interest. And as usual, the source code for this episode can be reached at the link under the video. The video is available at this URL here. Now, just to catch you up, in case you didn't see part 1, what we did in the last episode was a lot of automation and a lot of just getting React working properly. What we have now is a really fantastic set of automation where we are linting the code, compiling the JSX to JavaScript. React uses this internal sort of little language called JSX, which is a superset of JavaScript. I'll show you that in a minute. And in a production environment, you want to pre-process that. You want to compile it to JavaScript. So our build script does that. We lint it. We collate it. We're using Browserify for modules, so we have all that bundling together. And then we test it. We got unit tests working on the front-end code as well. It all went really smoothly. And of course, all those tests, as usual, are running cross-browser using Karma. We've got IE9, IE8, Chrome, Safari, Firefox, and iOS running here. We could, of course, use other browsers as well, but this is sort of my standard suite. The other thing we did as we were trying to figure all this out is we mocked up our application. What we're doing here is we are going to try to recreate the financial projector app that I did way back when in Java in React. And the reason we're using this is because it's a little bit more complex than your typical to-do app. And it's got some architectural decisions that are kind of interesting that I would like to explore in this part of the review. We'll get back to that later. So this is the mock-up. There's no logic here. It's not hooked up. It's just all hard-coded data. But this allowed us to see how React components work and basically get React up and running. Over the break, I took some time to style it. So if you saw the previous episode, this is a little bit prettier, just enough to make it worthwhile, I think. Now, to review how this works, this mock-up is rendered with JSX. Our main application starts right here by constructing the application UI. And then we use JSX. Again, that's that superset of JavaScript that React provides that allows you to sort of embed XML-ish HTML in your app. This is not real HTML. This translates into constructor calls on React. So they have a div class, they have an h1 class, and so forth. And the neat thing about that is it allows you to embed components right into your document. It's a lot easier than using React directly, which is kind of a verbose and ugly syntax where you have to constantly refer to React and so forth. So application UI provides the overview and also constructs the configuration panel and the stock market table. Here's our configuration panel. Here's the stock market table. Configuration panel turns around and has three configuration fields, which we've configured with starting balance, cost basis, and yearly spending. You can provide properties, attributes, just like you would in HTML. And then in a component, you can access those properties using this .props. And also, as you can see here, if you can close something in curly braces, then it interpolates the value into your code, which is kind of handy. So that gives us the starting balance, cost basis, and yearly spending field. Similarly, in our stock market table, we have the header, year, starting balance, cost basis, etc., and then 4 rows, which you can see here. Again, we've used the property to hardcode year value, which you can see over here. And then the stock market row just has that year pulled out of the properties and a bunch of hard-coded values. And I've introduced this negative class to turn the values red when they are negative. So that's a quick review of what we did in the last episode. Now, our main goal in this episode is to take a close look at how React works in terms of design and architecture. Specifically, when I'm working with a front-end library or framework, I have several pitfalls that I'm concerned about that I want the library to avoid. First off, I want to avoid a library that's going to lock me in. I worry that frameworks, because they have their own way of doing things, are going to control the way my application works so that when the library or framework is no longer appropriate, it's going to be really expensive for me to change that. So I worry about lock-in. I also worry about opinionated architecture. I have my own design ideas, and I've found that as a project develops, your design needs change. And if you're using a framework that locks in a particular design or architecture, and you can't change your design or architecture as your design needs change, that's a big problem. It can be really limiting. So I want to avoid a framework with opinionated architecture. Similarly, I worry about accidental complexity. A lot of these libraries are produced by people who love spinning their propellers. They like making things easy for some value of easy, but also very complicated. So when you get outside the bounds of what they expect you to do, it can be really complicated. Testability is also a concern. We've started to look at that a little bit. We'll get into it more in this part. And also search engine compatibility. Is the framework or library going to work with search engine indexes? Will it be indexable? That is a pretty important concern for most people on the web. So those are the kinds of things that we're going to look at. The way we're going to do that is by actually re-implementing this financial projector app. Specifically, we've got a mock-up. Now we need it to actually work. And I've chosen this example because it's got some interesting architectural design decisions. Specifically, we're using the whole value concept that comes from Ward Cunningham's checks pattern language, which is really a great pattern language. If you haven't seen it, I highly recommend it. We are using whole value and exceptional value, which basically says that we don't use primitives in our UI. We only talk about real objects. And in our case, we're going to talk about values like years and dollars and growth rate and tax rate. All of these things are things that we are going to directly talk about and that we want to be able to use in React rather than the actual primitive values. So that is a big part of how we're going to investigate the architecture and design constraints that React provides. Now, if you watch the previous episode, you can see here I've done a lot of work in between recording. I've basically brought in all of the domain and value logic, as well as a little fail-fast library from the original stock market projection application. We will get into what all this is in a bit, but just to summarize, the domain package here, or this folder here, is all about the domain logic of the application, how we do the stock market projection, what kind of values occur in each year. And the values directory has all of the domain-specific values we use. Again, dollars, growth rate, tax rate, and year. And we also have these invalid dollars, valid dollars, and user-entered dollars. That's a big part of the checks pattern language that allows us to do things like put in an invalid value and use the same calculations in our projections and have that just automatically work and go smoothly. All right, so that is our challenge to re-implement the Financial Projector app using React as our UI layer, but keeping the essential design of our domain layer and the whole value concept more or less intact. Can we do that? Will React allow us to do that? That is the question. If it does, that tells us something really nice about the lock-in and opinionated architecture questions. If it doesn't, then that's not so good. Let's see what happens with this. Let's start by trying to represent these whole value concepts in our UI. So right now we have these stock market table rows that are displaying values, but these are just hard-coded as strings. So if I bring up the stock market table row, you can see they are all just strings. What we need is the ability to render these out, and we don't want to render out a number 10,000 or a string 10,000. We want to render out a dollar variant. We have valid dollars, user entered dollars, and invalid dollars for various situations. In the stock market table, we're only going to care about valid dollars and invalid dollars. The invalid dollars, by the way, is how we deal with bad user input, as we are representing this with the underlying value object of a invalid dollars. This is a user entered dollars, this is an invalid dollars, and these are valid dollars. So what we need to do is have our UI actually render these values. And because we're using whole value, what they do is they actually render themselves. There is a render to method that you pass in a render target, and it will call a render method on it with the various data required to render. And all of our value objects behave in the same way. Years do the same thing. So what that means is that you can take any value object and ask it to render itself, and it works. What we need is for this to actually work with that. And we want to test drive it. So I think what I'm going to do, React is heavily component oriented, and I really like that aspect of it. I think what I'd like to do is create a table cell component. Let's go ahead and see if we can make this happen. We're going to need a test. So let's copy our stock market table row. We'll make this a table cell, and we're getting an error. It doesn't find table cell, which is exactly what we want. So I'm going to go ahead and copy table row. We are going to eventually have a render function in here, but for now I'm just going to return nothing. So in our test, our rendered value is going to be what? Well, a stock market table cell is going to take a value. And let's pass in, well, let's go ahead and pass in a year object. I think we should be able to say new year 1989. And we'll expect that to equal, well, just 1989, I think, inside of a table data cell. Okay, now it's failing because our render function isn't actually doing anything interesting. So now let's return just an empty TD. We got an empty TD, but we expect it to have a value. So we could make this pass by passing in 1989, but that of course is not what we want to do because that's just hard coding the value. What we want to do is deal with the fact that we've got this value object property. So we've got a value, and it's in this.props.value. And we should be able to just interpolate that, actually. There's a toString on the value objects that give us the correct answer. So this should work, and it does. That's great. But that's just the beginning, because we also need these value objects to render themselves as negatives and also to render themselves as invalid values. We need them to show this little icon when appropriate. That's what we need to get next. We've done actually a pretty nice job of test driving a simple little cell, but that's not enough. We need to handle the actual whole value rendering where it renders itself, where we call value.render2. So let's see if we can test drive that. For one thing, we need it to be negative. Let's say that it renders text, and that part we're already doing, but this will get our test going. So our cell is going to be testutils.render into document. Well, our table will be testutils render into document, table, tbody, tr, and then stock market table cell value equals new year. And we have to do the whole table, tbody, etc., because of a limitation of React, where if you just render something that isn't a complete valid element on its own, the DOM, the actual browser DOM, will insert all the stuff you're missing, and React will get confused. It won't be able to find the thing that you've created. So there's our table. Now the cell will be the first TD element. And the way we do that is we use the test utils scry rendered component DOM components with tag, and we'll look in the table for the first TD element, or for TD elements, and we'll get the first one out. And actually, there should only be one, so we can just say find render DOM components with tag. That gets exactly one, and it fails if there's more than one, which actually we want in this case. So there's our cell, and we should expect the cell, we'll get the DOM node, and we'll expect the inner HTML to equal 1989. And that should all work. There's no S in this case. That almost worked. Our inner HTML has got a span around it. React's putting all of its configuration information. So we need to go a little bit further to figure out what our value is. In this case, I think I'll just use text content instead. However, that is not supported on IE8. So what I'll do is text of cell to equal 1989. And then we'll write a little function. And if we have text content, we'll return that. Otherwise, we'll return inner text. And that should work. There we go. Okay, so that just gets us the ability to do some basic testing. Let's go ahead and factor out this part as well. What we're trying to do here is test this value. Okay, so what I want to do is say the cell is the test value, or better yet, DOM node 4 value. And then all of this can go into something that looks like this, and we'll return cell.getDOMNode. And here we'll just pass through the DOM node. Excellent. So that's nice. So now we've got the ability to do some basic testing of our stock market table cell. Next, what we want to do is we want to make sure that this renders negative values appropriately. If we look at this code I've done here, what we're doing here is actually styling negative values with a negative class. You can see it in our hard-coded stock market row, just giving it a class name of negative. We want the same thing to happen in our stock market table cell. We want it to detect if it's negative and style it with a negative class. So let's get a DOM node for a new valid dollars that's negative and expect the text. Now, in this case, the text of the cell should equal -10. That should work just fine. Oh, that's interesting. That isn't working either. And I'm guessing it's because we're not rendering it correctly. Yeah, I'll bet you we have to convert this to a string. Okay, there we go. So let's actually put this up in here. Now that we have that working, we need to support the negative values. And before I get into that though, I think I'm going to switch the stock market table cell from using toString to actually using the render method. And we've got our test passing, so I want to refactor it while our tests are passing rather than introducing a new test for negative. So the way this works is every value can render itself. And this is a bit archaic. It's following the style used in Java. And I'm doing that on purpose because I want to see how well React can work with what we've got. So we're going to say value.render2, and then what it takes is a render target. And the render target is something we have to implement. What the render target is it's a little class that has just one method in it called render, and that takes the render values. And those values are the text, whether it's negative or not, whether it's invalid, stuff like that. So if we dump this out, we're getting the text, whether or not it's negative, and an invalid value. So what we need is for somehow the stock market table cell to use this render2 to render the component. See, the render2 doesn't return anything, and yet React expects us to return something. So I guess what we need to do is we need to extract this out as our target, and then we need to return the target dot create component. And again, the whole reason for using this sort of bizarre thing is to see how well React can deal with something that's not the same architecture as React assumes. That's the whole point here, is we're testing how much lock-in and opinionation that we have with React. Can we use our own architecture? It may seem that this architecture is a little bizarre, and if I was building something custom for React, maybe we wouldn't use this architecture. But this is useful for determining whether or not React has the flexibility we need. And actually, so far, it looks like it's going to be okay. So when we're asked to render something, we need to store off the values. And then when we're asked to create the component, we'll take those values and return the appropriate thing. It's a bit clunky and a bit weird, but not too bad considering that we are using something that's incompatible with React. React is allowing us to sort of hide that complexity in the UI layer. The UI layer is acting as a translator for our domain layer, and that's exactly what we want. So that's pretty clean. I'm actually not too, I think that's pretty good. Let's see if that passes our test though. Kind of an important thing. It does. It does pass the test. That is excellent. So now we've got this using our rendering engine, and that's really good. So what we can do next is deal with negative values. So we should expect the cell's class name to equal negative. Right now it won't because we're not dealing with that. But when we render this out, we should be able to just say class name equals, if this dot values is negative is true, then we want the negative class to be negative. Otherwise, let's try making it null and see what happens. That seems to work. All right, well, that's good. We've got our negative value in there. Next, what we need to do is deal with a case where the value is invalid. In that case, we want this little icon to show up and no text, as well as a tooltip that says invalid dollar amount. Those are handed to us in the rendering values, so it should be fairly straightforward. We want to render invalid values with an invalid icon. We'll just make a new invalid dollars, and then we should expect it to contain, I guess, an image. And I'm wondering if maybe the easiest way to do that would be to, again, use the static rendering approach. And we'll expect the rendered value to equal, it's going to have a TD, an image with some href that I'll figure out in a moment, and that may be it. That should be fairly easily fixed. If we're invalid, we're going to do one thing. Otherwise, we'll do something else. But here we'll just return TD image href equals something, closing bracket. Okay, there we go. I also corrected my href to source, and that should work, and it does, and it should also show up here now. And there we go. I went ahead and replaced the starting balance with invalid dollars, obviously. So yeah, that's looking pretty good. Next, what we need to do is get the tooltip. We don't have a tooltip yet. That should just be a simple matter of adding a title to our data element. And that's easily implemented with this .rendering.tooltip. There we go. Invalid dollar amount. Perfect. Well, that has come along pretty smoothly. It's a little awkward, this interaction between the table cell and the value object. And again, I could refactor the value objects to work more smoothly with React. But the idea here is that the render targets are supposed to provide a translation between the value objects and whatever UI layer we're using. And that is actually working really well here. So I am pretty happy with this. I would say that this is a success. React is not showing a lot of lock-in here. It's not being excessively opinionated about the architecture. It's really working quite well. And I think we've gotten all of the important things for the cell rendering as well. So that's pretty good. So just to review, what we've done here is we've test-driven a stock market table cell, which can take any value object in our system and have it render itself. And rendering means that we need to look at whether or not that value object is invalid, deal with tooltips, deal with negative values, which we want to be displayed in red. And again, do that all by having them render themselves. And we've gotten tests around this too that are pretty decent, pretty clean here, where we can say things like expect the text of the DOM node to equal 1989. I really am pretty happy with this. I'd say that this all works out pretty clean. Now that we have the table cell implemented, I'm going to go ahead and do the same for the row and the table itself. That should be pretty straightforward. I just need to hook up the actual domain objects. The table looks at the stock market projection, and each row represents 1 year. So I'm going to go do that and be back in a moment. Okay, I'm back. That was pretty straightforward. Implementing these was really easy. There was one little catch that was a problem, and I'll get into that in a moment in the tests. But overall, it's pretty good. So let's start with we've seen the cell. The row is just a matter of having all the cells, and we get the year in as a property, and then we just look up all the values that we want, and we flip some of the signs so that they look correct. And by the way, so you can see this is what it looks like now. So we've got all the calculations happening and all the values being rendered properly, and I'm really happy with that. So the table row, really straightforward. We just look at all the values in the year and ask the cell to render them, and it automatically takes care of the rendering for us. And then for the table's a bit tricky. We need to put all the rows in, and this is where JSX falls down a bit because it doesn't allow us to do any looping inside of the JSX part of the code. This has to be a purely functional approach because it's an expression, not statements. So what we do is we create the rows up here and then paste them in here, which is just a little bit awkward. It's not terrible, but it is a little awkward. The other thing is when we're putting things in an array, we have to put a key on it, which will make sure that React doesn't mix them up as you move them around. Now we're not actually moving rows around, but we still had to put the key in. So that, again, pretty straightforward. The table is just a bunch of headers and then a bunch of stock market rows. And then the application UI, and this, of course, takes our stock market projection. And right now, our application UI creates a stock market projection out of hard-coded data and then passes that into the stock market table. The tests were also pretty straightforward. The row test was pretty much just a reflection of the actual row. We're checking to see that each cell is correct. And the table test, that got a little more complicated because I wanted to compare the first year of the table to an expected first year, but React doesn't have any way of doing that I could see. So I had to sort of hack away a little bit and poke into the internal private data. That was not great. And it just sort of, either I'm missing something or perhaps what this is it's another example of how React's testing story is still a little bit immature, that we don't have a way of comparing a component to an expected value. We can get the component, no problem. We just say, give me all the components of a particular type, which worked great. So that gives us all the rows, and then we just take the first one out. But then comparing them, I had to render them to static markup using this sort of workaround, which worked well, but it is using an internal implementation detail. That is probably okay in a test because if it breaks, it breaks. The test fails, it's all good. But it's still a case where I'd like React to have a better story for comparing components. So that's that. We do have everything working now. The mockup is using real data. Next, what we need to do is to get our configuration panel actually taking in data, because right now there's nothing happening here. So there's two parts to this. First, we need to get these to respond to events and handle the rendering of the value objects so that when we put an invalid value, we see a little exclamation mark here. And second, after that, what we need is to hook up the configuration panel to the stock market projection. Okay, I've factored out the configuration field object. That's each one of these is a configuration field. And right now it's not doing anything of interest. It's just setting up a label and an input form. Now, the way React works with forms is that when we have an input like this with nothing in it, it behaves like a normal input. But as soon as we put a value on it, such as 1, 2, 3, then it's locked in place. At least that's my understanding. I haven't tried it yet. So let's go ahead and run that. Yeah, now these are all locked in place. We cannot change it. I'm typing on the keyboard, but nothing is happening. So I think the first thing we need to do is deal with this value changing and figure out how to do that. And of course, we want to do that test driven. So let's write a little test. I've got a do nothing test here. What we want to do to start is to just say that it starts with a value. So we can pass in a dollar amount, or really any value object, and it will display that value. So it displays initial value. And I think typically what we're going to want to have is a user entered dollars. Now, just to remind you, our value objects come in three forms for dollars. We've got user entered dollars, valid dollars, and invalid dollars. User entered dollars represents the text that somebody actually types in, and it's different from valid dollars and invalid dollars in that it chooses its state between valid and invalid depending on what the user types. So underneath the covers, a user entered dollars is either a valid dollars or an invalid dollars. And they're immutable, so it doesn't change its state. We just create a new one whenever we want. So the initial value, what we're going to do is we're going to create a configuration field with a value, and let's make a new user entered dollars with 1, 2, 3 in it. So now let's go ahead and expect that to equal 1, 2, 3. So it should equal the value we pass in. This will fail because we are getting foo. There we go. So now what we need to do, and this is a bit tricky, components need to maintain their state. So we will take that initial value, and in fact, maybe that's what we should call it, is initial value. Now we need to take that initial value and store it off. And the way we do that is we need to maintain state for this field. We need to actually have the field know what state it has, what text it has in it, and manage that state itself. And what we'll do is we'll change the state when the user makes changes, when the user types. To store that initial value, what we need to do is implement a new function called getInitialState. This initializes the state of the component. So we'll say function getInitialState. So the initial state is really just going to be this .props.initial value. So the initial value we're passed in becomes our initial state, except that we want to make it an object. So let's go ahead and set that initial. Let's make our state have a value of initial value. And then here in value, what we'll do is we will actually return this .state.value. .getUserText, the actual value that the user entered, and have this work. Yeah, that's done it. So this is working now. We are actually setting this to its initial value. Now, if we go into our configuration panel and put in an initial value like that, we should see this when we run the application. And there it is, 1, 2, 3, 4, 5, 6, 7, 8, 9. And those are not changeable because the input field is now controlled. We gave it a value, so that value is always going to be exactly what we said it is. Now what we need to do is to make sure that the value changes when user changes the input field. And this is a bit tricky. What we need to do is handle the change event that React provides, and I think this is a synthetic event that it sort of adds to its version of the DOM. The change event fires when the value of an input field changes, or a check state changes, or select state changes, as with a drop-down list. So it sort of handles all possible changes, which is nice and convenient. Now, what we need to do is just handle that change event. We need to add a change listener to the field and then implement it so that it changes the state. And that actually seems pretty straightforward. The trick is test driving it. How do we actually write tests that will simulate that event? I know that React's test utils has the ability to do that, so I'm going to go ahead and look into that and be back in a moment. It looks like what we do is we just say simulate change and then pass in what we want. So let's try that. We're going to say testutils.simulate.change change the input field, and change it to a value of foo. And now we should expect the value to equal foo. So we expected 1, 2, 3 to equal foo. Now to implement that, it should just be a matter of adding a state handler. So we've got the text, we've got the value, and then we want to say onChange equals this dot onChange. Or rather, let's say handle change to be consistent with the React documentation. Then we're going to add a handle change method to our class here. That takes the event. And here what we want to do is we want to set the state. We want to change the state. So the way we do that is we say set state, and we pass in a new object with the value of, in this case, rather than it being the initial value, we're going to create a new user entered dollars, pass in the event and target and value, I think. And set state needs to be called on this, and this needs to be a capital C. Let's try that. Well, it didn't work. Okay, I got it. We have to actually put in the target as well. So we have to put in everything that we are expecting. We have to put in the entire event object that we care about. So put in the target and the value, and there we go. So there we have it. We have successfully test-driven a configuration field that changes its value. Now, we're not quite done yet because we also want this to display the invalid object or the invalid dollars little sigil. Just to refresh your memory, if we bring up the Java version, if we put in an invalid value here, we get a little exclamation mark here in the corner. We want our text field to do the exact same thing. Now, I think the easiest way to implement that from in HTML would be to do it with a CSS property. So I'm going to put a class on here that says we're invalid when we're invalid. So there we go. We've got this rendering properly. Now, again, it's a little bit odd. I don't know if I really like it, but that is how our system is designed right now. And React's handling it pretty gracefully. Okay, I've styled the invalid class, and it is beautiful. It works really well. I love it. Now, and it even handles the case when the numbers get too large, because that's all handled by our domain layer. Excellent, excellent, excellent. All right, this brings us to the final stage of our example application. What we need to do now is hook up these configuration fields to this stock market table. So right now when we make changes here, it is live. We are connecting up to our value objects, but it's not actually filtering through the application. And this is a bit tricky. And actually this sort of problem is, in my experience, one of the most challenging ones of UI development. It's very easy to make components, but how do you make those components talk to each other? Well, the React solution is to manage state at the highest level you can. And that makes a lot of sense. That's actually what I did when I implemented in Java. Now, again, I did have my own architectural approach to this in the Java application, and I want to try to bring that over to the React example that we have here. And the way I did it was I implemented another package, which you haven't seen before, which I called persistence. And the reason I was called persistence is it also would manage talking to the file system or database, or in the case of a JavaScript app, it might talk to the server. It might actually handle real-time communication with the server as other people are making changes. The idea, though, is that all your data is stored by objects in this persistence folder or persistence namespace, and it's solely responsible for dealing with communication to other systems or to the file system or anything that involves the outside world. So user configuration is our object in the persistence layer, and it represents all the configured state of the system, which actually meshes nicely with the way React does things. So what we need to do is to create that user configuration and have it filter down through to these values. Now, how are we going to do that? Well, that's a bit of a trick. We have a configuration field so far. What we don't have is we don't have any tests around the configuration panel. So if we look at the configuration panel, here it is. It's just hard coding a bunch of values. What we need is for it to take these values out of the user configuration object. So let's go ahead and get started on that. There we go, pretty straightforward. I'm testing each of the configuration fields, and then actually implementing it is a simple matter of getting the correct value out of the user configuration. The real challenge, though, is how do we get changes back into the user configuration? And that's a bit of a trick. We need a way to get the information from the child back to the parent. Getting the information from parent to child is really easy. We just look in properties. Getting information from child back to parent, well, that's a bit more challenging. What we need to do is provide an event handler. Basically, what we want to be able to do is we want to say that when the configuration field changes, we do something. And that means we need to go back to our configuration field and implement support for an onChange property. Okay, here we are in the configuration field test. We really just need to write something that says that it calls event handler when user changes the input field. So we'll set up a field with the value we want, just like we've done in the other tests. But this time we're going to add an onChange, and we'll just call a little function that we write here. And I'll write the handler function right here. And what this is going to do is just set a variable to true. So we're going to create an event triggered variable up here, set it to true when the handler is called. So what we can do is we can simulate a change like that, and then expect event triggered to be true. And when we run this, the answer is going to be no, it's not going to be triggered. Of course, we need to put braces around that, and we'll need to pull out the input field that we're going to simulate the change on. So let's try that. Okay, it's saying that the event was not triggered. Implementing this should be pretty easy. In our existing handle change function, we should just be able to say this.props.onChange, and that should cause our test to pass. But it didn't, and that's because our other tests don't have an onChange. So what we need to do here is put a guard around it. If it exists, then we'll call it. And there we go. Now let's make sure that it actually comes through with the value we want. You can see right there it says expected undefined, but we did get what we got, foo. So here we'll pass through event.target.value. And there we have it. Okay, now that we've got that onChange event implemented, what we need to do is make sure the configuration panel uses it to modify the user configuration. So we'll make a new test that says changes to configuration fields are applied to user configuration. And now what we need to do is we basically need to say, well, we need to simulate the change or cause the change to occur, but I don't want to just dig into the input field as we did in the configuration field test, because that's encapsulated. That's a detail of configuration field, the way it renders, that I don't want our other classes to have to worry about. So I think what we want to do is add a function to configuration field that can be used to simulate change. We'll do something like this: field 0 simulate change and some arbitrary change. And then we'll expect the starting balance to equal that new value. This, of course, isn't going to work because we don't have a simulate change. If I run this, the test will fail. So I'm going to go ahead and comment this test out for now, go back to configuration field test, and test drive that simulate change method. Okay, I've got that simulate change method implemented. I also took the opportunity to clean up these tests, get rid of a lot of duplication. And it's really straightforward. There was one catch, which is that you have to call render into document on whichever component that you want to call a method on in your test. There's other ways of doing it in your production code involving the refs property, but we don't need to worry about that because this is just for testing. So as long as we've rendered into the document, we can just call methods directly on the component, and it's just that simple. And implementing it, simulate change just turns around and calls handle change with the appropriate property. It's works really well. So now that we've got that working, we can go back to our configuration panel and re-enable this test. Remember, what we want to do here is we want to simulate a change on the starting balance field and see that the user configuration starting balance has actually changed to match. Now, when we run that, that should fail. We do have a simulate change, but as the error says, we haven't set the onChange property of our configuration panel. So what we need to do now is go ahead and set that. We'll say onChange, So now implementing this is a bit of a trick. Let's go ahead and we'll just say handle change for now. So write a new method called handle change, and that will get the new value. And to start with, we can just say this.props.userConfiguration.set starting balance to not just any value, but a new user entered dollars with the new value. And here we'll call this.handleChange, and that should work. So we'll continue on and do that with each of the others. There we go. And when we run that, we get the failure doesn't support onChange. Again, we haven't actually added onChange to these. Now, the trick here, though, is that if we put onChange on here, it's going to call handle change, which is going to set the starting balance. So we either need one handle change for each field that we care about, or what we need is a generic change handler. And that's what I'm going to implement now, is just a generic one. Specifically, what I'm going to do is I'm going to bind in another value, which is the function to call, the setter function. So here we'll pass in this.props.userConfiguration.setStartingBalance. And the way we'll do that is by calling this.handleChange and binding that to that new function. This is a bit of a trick. It's a bit obscure. Basically, it's a way of saying always pass this parameter in as the first parameter to this function. And you can add as many as you want. And this is just saying which object to act as if it's called on. So if we do that, if we make this take that setter function, then what we can do is call the setter function with our current this value and pass in new user entered dollars, new value. Of course, we'll have to say call here. And actually here we don't want to pass in this, but we want to pass in user configuration so that we're calling the setter function on the user configuration object. And there we go. So now we can go ahead and implement that for the remaining fields. And it works. Okay, so what we've done here is we've modified configuration panel so that whenever the user changes the starting balance, cost basis, or yearly spending, when they change those fields, then we're updating the user configuration. And that's fantastic. Now what that means is that we can take that user configuration and use it in our application UI to set the stock market table. So here we are in the application UI. What we need to do is set the user configuration on the configuration panel and then listen for changes on the user configuration. When the user configuration changes from any source whatsoever, it sends an event that we can handle. When we catch that event, what we'll do is we'll update the stock market projection here. First, what we need to do though is get some tests around this. I'm going to do that. Be back in a moment. Okay, I've got some tests running here, and I've also modified the application UI to take a user configuration as a property and pass it through to the configuration panel. So we're all set so to have the stock market table update when the config updates. And the way I want to test that is pretty straightforward. I'm going to say that we update stock market table when user configuration changes. So what we'll do is we'll say config.set starting balance to new value, and we'll check that that table is equal to a table that uses our config. This check component is a little function I wrote. React doesn't have a way to compare components that I can tell, and so I'm just rendering them to static markup and comparing the results. That leads to some pretty ugly output when a failure occurs, but this is the most convenient way I know of to compare components. It also is delving a little bit into the internals React. So I don't love this check component function, but I really don't know of any other way to compare an expected component to an actual component. This function here, the table, is just pulling out the component I'm looking for, the actual component. So this should fail because we're not currently re-rendering the stock market based on changes to the user configuration. Oh, but actually we got it failed fast because I put in a string rather than a user entered dollars as I should have. Okay, now it's failing for the right reason. You can see that big ugly failure from our check component. Luckily, Luckily, I know exactly what's going on here. We have not modified the stock market projection. So what we need to do is we need to listen for changes to the user configuration. This requires a couple of things. First, when we're initialized, we need to start listening for change events on the user configuration. And the way we do that is by monitoring this component did mount function. So I'm going to, or actually writing a handler for component did mount. This will be called after the component is mounted, or that is when the component is ready to render for the first time, or something like that. I'm not entirely clear on the life cycle, but this happens only once per component. So what we need to do here is we need to write ourselves a little function that says when the config changes, we're going to do something. And what we're going to do is tell the component to re-render itself. So we say this dot force update. Alternatively, if we had some state to change, we could change that. But user configuration is changing down into its bowels. There's no state of ours to change. So that's the first thing to do. This, I don't think it's going to work though, because the other thing we need to do is, well, as you can see here, we need to have a config object to work with. We don't have a config object here. We could say this.props.user configuration. But how do we deal with this new user configuration idea here? So what I'm going to do is I'm actually going to pull out the config from the props and store it in the application UI state. So that requires us to implement another method, get initial state, and we will store off the state from this.props.user configuration or new user configuration. And now here in component did mount, this is going to be called right after get initial state is called. There's actually a couple of functions you can implement. There's component will mount and component did mount. Did mount is the one we want. What we're going to do here is we're going to look at our state and say that when the config changes, we're going to force an update. And that should cause, that will listen to any changes for users to our user configuration, including this one right here. And it will force the application to update, which will cause the render to rerun, which will re-render everything based on the current state of our config. So that should make our test pass. There is one catch though. This is the wrong this, so I'm going to go ahead and change that to self, like this. We could also use bind, but I feel like this speaks a little more cleanly. And there we go. So now what we have is an application that automatically updates itself based on changes to the user configuration. And it's really straightforward and clean. I really do like it. Let's go ahead and see how it looks. Reload that, and there we go. Everything is working perfectly. I love it. It is done. Well, almost. We're not quite done. This application is working now, and that's really fantastic. But now that we have the state management happening up here at the application UI, we don't need it down in the bowels, in the user configuration field. And this is something that React really emphasizes, is your state management should happen at the top levels of your application and then filter down into the rest of your application using properties. So we only need to manage state at the application level, or whatever your common components are, not down in the details. And that's something that actually I really like and has the potential to make things nice and clean. So what we can do is we can actually take out all of the state management that we have here in our configuration field. So we don't need this test right here that says the value changes when the user changes the input field. And here in our configuration field, we don't need to do any state management. We can take out this state, set state, and this get initial state, which does a nice job of simplifying the code. Now, to make this work, we have to replace props with initial value. And in fact, we'll change the name of that from initial value to value. We'll change this to props from state. And because our application UI passes through the correct properties every time they change, because remember, when they change, we force an update, which causes this to get re-rendered, then this will just automatically have the correct value. So let's go ahead and run that test. Everything's still working great. And let's confirm that it really does work. And yes, it does. We're still getting updates here, even though we're no longer managing any state. And that's a feature of React I really like because it simplifies the components really nicely. Your typical component only cares about how to render itself. It doesn't manage any state. It doesn't worry about any of that. It just says, given these values, how do I render it myself? It's very functional and very deterministic, which makes it easy to test and easy to write. There's one last thing I want to look at before we call it quits today, and that is looking at what happens when other things cause changes. So for example, right now, React is handling the situation where we make changes to these values really nicely. It works perfectly. But what happens if somebody else changes the user configuration? Now, the architecture we have should support that nicely because user configuration handles all of our communication with the outside world. And the application UI is the only thing that looks at user configuration, and it automatically updates the configuration panel and the table when it changes. As a result of this architecture, we should be able to react to changes to user configuration from other sources. That's something that's really important. That's a common cause of issues in complex user interfaces. And the way I'm going to simulate that is by just modifying your user configuration to have an interval set where it's going to automatically change itself every half second. And what I'm going to do is I'm going to set the yearly spending to a new value based on the current user spending. We're just going to add $1 to it. And let's go ahead and convert that to a string, and we'll make that into a new user entered dollars. Now, this isn't how real code would work, but this is just an example, and this would break all of our tests too, so I'm not going to check it in. But if we do that, we should see the yearly spending go up by $1 every second or every half second. And there it goes. Excellent. And we should still be able to modify all of our other values seamlessly while that's happening. That is beautiful. I love it. I love it. I love it. I love it. This really proves that React is working seamlessly with our existing architecture, and that is very nice. That brings us to the end of our special on React. I am really liking React. Let me just recap what we've done here. We've created a little financial projector in React, and that has a configuration and a table, and the configuration is something that can be persisted to the server and updated from the server, as we have emulated with this auto-updating yearly spending. The way this is implemented is in several layers. The value objects handle things like dollars. The utility is just fail fast stuff. The domain layer handles our projections. Persistence layer handles our configuration. All of that is unchanged. The idea there was that I wanted to use an existing architecture that was not designed with React in mind, to see how well React could deal with something different than what it was designed for. And it worked really well. The bulk of the React code, well, in fact, all of the React code is right here in this UI package. It starts out with our main.js, which just constructs our application UI. That is our component for rendering the application. It manages our user configuration state, and it sees when that changes, and when it does, it tells it to update itself. It renders itself, as all components do, very nicely. React has a render function where you just say, this is what the component looks like right now, and React figures out what that means in terms of changing the DOM. The rendering says, give me a configuration panel with our current config, and give me a stock market projection with a projection based on our current config. Also, very, very clean. The configuration panels have 3 configuration fields. You can see how it'd be very easy for us to add more. We're not going to do that in this series, but you can do it yourself if you'd like. The configuration panel does not manage any state of its own. It just takes that config that's passed in, gets out the starting balance, the cost basis, and the yearly spending. Those are the 3 values we care about, and says, give me a configuration field, 3 configuration fields with those values. The configuration field itself, again, no state management. Even though it's a text field, it gets all of its information from the value property. However, it does notice when changes are made. On a change, it will call a function that's provided by the person who creates it, and it also gives you the ability to simulate changes. The important thing here, though, is that in the render function, we connect to our value objects. They have this sort of bizarre way of rendering themselves that you call the value object, tell it to render to a target, and the target is supposed to translate between whatever it gets and the UI layer, which is exactly what we're doing here. We get those values, we save them off, and then we create the component. The component is just a simple div with a label and an input, and when that input changes, we propagate that up to the configuration panel. Now, coming back to our stock market table consists of a table with a bunch of headers and then a bunch of rows. The rows are based on the projection that's passed in. Again, that's done through properties. We don't manage any state here, so the render function is all there is to it. It's very straightforward. We get that projection, we loop through all the years that it has, and we add a stock market row for each year. The stock market row, in turn, consists of nothing more than a bunch of cells. We extract out the various data from each from our stock market year to populate those cells. And then the cells, once again, those are simply value objects. They know how to render themselves, same way that the configuration field does. We store off the render information, we create the component, in this case, as a table data tag. And that's either invalid or valid, depending on how the rendering is supposed to work. And that is all there is to it. It's all getting configured by application UI, which is all based on the user configuration object, which is in our persistence layer, which means that as the user configuration object updates, our application updates, which is how we get this lovely real-time view. It is a very, very nice system. I'm very happy with React. It is pretty sweet, and I have to say, I do recommend it. And this is a surprise for me because I came into this, I don't like front-end frameworks. I usually find them to be too controlling. So React being so good is pretty impressive and surprising. Let's see how React performs on our list of framework pitfalls. The first one is lock-in. Does React prevent us from doing our own thing? Does it prevent us from switching to another tool in the future? I would say no. It's actually really solid. It's not perfect, of course. It does have this custom DOM, which means that anything you write in React, if you switch to something else, it is gone. You have to throw it away. You've either used JSX or you've used the React constructors directly. None of that will port to another framework. So any UI you create with React, yeah, that's locked in. But very much in React's favor, it didn't control anything except the UI, and it does allow you to plug into just a subset of the DOM. So you can use React in part of your page and use something else in another part. So overall, I would say that this is a toss-up. The lock-in is not bad, but you will have to throw away any UI you create with React if you want to switch to another tool. Opinionated architecture. Fantastic. There was no problem here whatsoever. I used my admittedly quirky architecture with React and did all the value object stuff, and we translated them through here. We used the user configuration, and not only did it worked really, really well. I would say that React may be one of the best I've seen in terms of allowing me to use my own design and architecture. Accidental complexity, also really, really good. React has a nice thin API. There's not a lot to it, but there's in terms of what we have to manage as users of React, but it's very deep and it's very sophisticated, and it does a lot of hard work under the covers. That said, there is some accidental complexity in terms of the virtual DOM. The virtual DOM that React provides is what allows it to do its magic in terms of writing simple render functions that just talk about what you want right at this moment. But it's not a real DOM, which means that you are going to see some complexity there, some accidental complexity, some unintended complexity resulting from that. I've already heard people saying that focus management can be a problem. As I was researching React, I heard issues about using CSS transitions. Anything that is new in the DOM that isn't already supported by React or really tied in with the way React thinks, you're going to have trouble using it, or it's going to be delayed. That is going to be a source of complexity. So I would say that this is really good in terms of how the React API design is. In fact, it's excellent. And one of the things that we didn't get into that I really liked about React is that it really shows that it's used by people who are solid engineers. I mean, they have the idea of being able to specify how your components to be used and stuff. It's all really good stuff. Fantastic API, really like it. But that virtual DOM, that is going to lead to problems over time. That will introduce complexity. That complexity, however, is probably not going to be too bad, and I think could well be worth it. Testability, or rather poor testability, is a common pitfall. React did really well on this front. We were able to test everything, and I do mean everything. It was all unit tests. Didn't have to use any mocks at all. If you've been watching my stuff for a while, you know that I try to avoid using mocks. I see a lot of mocks as a sign that maybe you've got some design problems. So the fact that we were able to test without using mocks was fantastic. That said, I did have to write my own tool for comparing a component to an expected value. There is no way in React that I see, although it may just be poorly documented, but I didn't find any way to say, given this component in my test that I've actually created, how do I compare that to an expected value? Now, I was able to implement that myself, but it did not get implemented very well. I had to dive into the internals of React, and I also do it just by comparing static renderings, which gives terrible error output. So overall, the React testing API looks and feels just a little bit immature yet, and I would say the biggest flaw is this no ability to compare components to expected values. But being able to do it without mocks and doing it all with unit testing and having the tests run nice and fast, that was really good. So I would say that the React testing story is already pretty good. I just think it could be a bit better. And then finally, search engine compatibility. We didn't really get into that, but unusually for a front-end framework, React does have an answer to this problem in that you can actually render components on the server. We've got this render component to string, which allows you to serve data that you can then use with React on the client, and also render component to static markup, which just turns it into regular HTML. And we use that in our test, so I know it works. Congratulations, React. You actually solved the search engine compatibility problem. Nicely done. Bottom line, I like React a lot. It is one of the best libraries for user interfaces I've come across. It's really good. I would definitely recommend it for anybody looking for a front-end tool to help them create single-page apps, or maybe even just sophisticated full websites. I do worry a bit about the lock-in. If you do a lot of UI work in React, you are stuck with React unless you want to re-implement that all. But that said, it is really hard to find a front-end tool that doesn't have some sort of lock-in, and the rest of React is just, it's really good. That is it for our special on React. This has been a huge special, a lot of work. Thank you all for joining me. I hope you enjoyed it, and I will catch you next time.